Welcome to Netcom channel. This is Gerald. Today we are going to see part 3 in Open Shorter Spark first. In last two sessions we saw what is OSPF, what are the areas, what is area, what are the types of areas, and what is virtual link. And today we are going to see the different network types in OSPF. There are 5 different network types in OSPF, and they are point-to-point, broadcast multi-access, point-to-multi-point, non-broadcast multi-access, and point-to-multi-point non-broadcast. To see what's the need of OSPF network types, through various WAN services, routers can be connected and they provide IP connectivity between the devices. To calculate the adjacency and discover the best path, OSPF must know the important properties of the network between the routers. Some WAN services support full mesh communication, some support hub and spoke, and some broadcast, multicast, and point-to-point. There are different WAN services as discussed, and which can be a point-to-point through direct cable and Metro Ethernet, Wi-Fi, frame relay, etc. And these 5 OSPF network types account for various WAN technologies and their properties, and the network type is configured on interface basis. And this tells the OSPF process how to establish and maintain neighborship over the given interface. The first type is the point-to-point network type. Here it connects the two routers directly, and the default hollow interval between the routers would be 10 seconds. And since we have only two routers, there is no need of DR or DR and BDR. They discover neighbors dynamically, and the default network type is on serial interfaces if we take as a physical interface, and GRE and IPsec tunnels for virtual. And the below command is used to configure the point-to-point network type. Go to the conf.t, go to the interface serial, give IP OSPF network point-to-point. And the next one is the broadcast multi-access. Here, multiple routers can be connected to the Ethernet segment. So if you see this diagram, there are 4 routers R1, R2, R3, R4 are connected. And since here multiple routers are connected, the default hello interval would be 10 seconds. And like point-to-point, they discover neighbors dynamically. And here there is a need of DR and BDR election. Since we have multiple routers, and in order to manage the LSA flooding, we need the designated router and the backup designated router. And here they are default on the Ethernet interfaces. And apart from Ethernet, you can have fast Ethernet, gigabit Ethernet, etc. And the command to configure on the interface is IP OSPF network broadcast. And the third one is point-to-multipoint. Here a single router connects to multiple routers on different subnets. And here also the default hello interval would be 30 seconds. And this works on the concept of one-to-any connectivity. And here they discover neighbors dynamically. And here they don't use DR or BDR. Instead, hub acts as a DR. If you see this diagram, R1 acts as a hub and R2, R3, R4 acts as a spec. So there is no need of DR or BDR election. And the example media here is frame relay with sub-interfaces. The command to configure is IP OSPF network point to multipoint. The next one is non-broadcast multi-access. When an OSPF interface is configured as NBMA, below things are possible. We can connect unlimited routers through this interface. Since multicast is not possible, we cannot discover neighbors dynamically. A neighbor should be predefined by the administrator. If you see the configuration, after enabling the command IP OSPF network not broadcast, under the sub interface, we map the neighbor IP manually, which is 10.12.3.1, and use the protocol frame relay here. And 201 is a DLCI, which we call it as data link connection identifier. It is a local link circuit identifier, which is used to send the frames over the VPC. And since multiple routers are connected, DR and BDR is required here to optimize the LSA flooding. The next one is the point to multipoint non-broadcast. Here, when an OSPF interface is configured as a point to multipoint non-broadcast, the connectivity would be like hub and spoke. And since multicast is not possible, we cannot discover neighbors dynamically. A neighbor should be predefined by the administrator, like the previous one, non-broadcast multi-access. Here, hub router optimizes the LSC flooding, so DR and BDR election is not required. The command to enable point to multipoint non-broadcast network tag is IP OSPF interface point to multipoint non-broadcast. So these are the important OSPF network types. If you like the video, please like and subscribe to my channel. Thank you.